In previous lecture, I have discussed about the concept of, or you can say the basic concept of system. What is system? What is the role of the system? What is the need of the system? And its type. So go through that video uh, to understand the basic concept about the system. System is basically a sets of element, or you can say a sets of functional block which are connected together to produce response. To produce response, or you can say output for a given excitation or input. Here input is termed as excitation also, excitation, and output is termed as response. So system is basically sets of elements which are connected together to produce response for given excitation. When you will excite the system through some input signal, then corresponding to this excitation, system will produce response for that excitation. So basic thing is system will have input, and corresponding to this input, system will provide you, system will produce output. So this is the basic concept about the system, which already I have discussed in the previous lecture. Or in a simple language, you can say system is an entities which will extract valuable information from the input signal, because the signal will carry some important information, and there is a need of a device to extract that information. And the device which is needed to extract the valuable information or important information which is included in the signal can be termed as system. So there are various ways through which you can define a system, but the basic thing is system will have excitation, system will have input, and corresponding to this input, system will produce output. So this is the basic concept about the system. These all concept already I have discussed in the previous video. System can be realized through hardware, system can be a software, system can be a process. All of the thing in which if you will supply or apply input, and if that block or that entity, that program, that process will give you a output, gives you output, then you can say that entity, that block, program, process will be a system. So this is all about the system. Second thing which I have discussed about the system is, as you see here, system will have excitation, system will have inputs. You will have to apply input to the system, and for this input, system will convert or system will produce corresponding response value for that excitation. So system will have input and system will have output, and this output input is related with some mathematical expression, or you can say there are various ways through which you can uh, represent system. System can be represented through a block diagram. System can be represented through a circuit diagram. System can be represented through a signal flow graph, and system can be represented through a mathematical expression or sets of mathematical expressions. So there are various ways to represent uh, the system, and one of the most important way through which you can represent the system, or you can analyze the system easily, is its mathematical representation. So system can be represented mathematically uh, with a sets of input output relationship or a input out relationship. So there must be some mathematical relationship between input and output, and you can say this input output relationship of a given system is the mathematical modeling of that system. So you can model the system through mathematical equation. You can model the system through circuit. You can represent the system through blocks of element which are connected together to produce response. So there are various ways through which you can represent the system, and one of the most important way through which you can represent the system is their mathematical representation or mathematical modeling, because through mathematical modeling you can easily analyze the various characteristics of the system. You can draw the various characteristics of the system. So mathematical modeling is very important for the analysis of the system to identify the type of system. So if a system must have some mathematical relationship between input and output. And the third thing, its response will be dependent on the excitation. Whenever you will change the excitation, obviously its response will change. So its response will be a function of input. And symbolically, system can be represented as xt, then you will have to put arrow and then yt. It means this is a system and response of this system is yt if excitation, if system is excited with input energy or input signal xt. If you will give excitation xt, then this system will give you a response yt. So this is the symbolic way to represent the system. So all of these contents already I have discussed in the previous video, and its types also. There are two types of system. One is CTS, continuous time system, and another one is discrete time system. So already I have discussed about CTS and this DTS. So without wasting time, today I am going to start how you can identify linear system. How you can check the given system is linear or non-linear. If mathematical modeling of the system is given, then you can easily identify through some steps that it is linear or not. So today I am going to discuss when you will say the given system is linear system. So first I am going to define the linear system. A linear system is basically the system which follow the principle of superposition. When the system will follow the principle of superposition, then you will say the given system is linear. And this principle of superposition, uh, has two components. When these two components will satisfy, then only you can say the given system is satisfying the principle of superposition. One is additive property. One is additive property. Additive property. And another one is principle of homogeneity. Principle of homogeneity. Principle of homogeneity. So when you will say the system is linear, the answer will be any system which satisfy the principle of superposition will be said as a linear system. But what is the principle of superposition? Principle of superposition has two components. One is additive property and another one is principle of homogeneity. To satisfy, to obey superposition principle, the system must have to obey additive property and principle of homogeneity simultaneously. If these two are the condition, if any system satisfy these two conditions, Then only you can say the given system is obeying the principle of superposition. So one by one I am going to discuss what is the meaning of additive property and what is the meaning of homogeneity. So let us consider this is a system A. This is a system A, and if you are applying or if you are giving excitation x1t to this system and corresponding to this excitation response is y1t, then symbolically you can write x1t. Uh, Symbolically you can write x1t and then arrow and then y1t. Suppose for the same system you have changed its input. Change it for the same system. You are changing its input to x2t, and for this excitation response is y2t. Y2t. Then symbolically you can write x2t arrow y2t. Now, if I am saying that this system A is satisfying principle of additivity or additive property, it is satisfying the condition of additive, or it is obeying the additive property. It means when you will add the excitation, when you will add the excitation to the same system A, its response will be added together also. This is the meaning of additive property. Additive property means if any system is giving you a response of y1t for x1t and the same system is giving you a response of y2t for excitation x2t. If for the same system you will add these two excitation and response is also added together, then you will say the system will obey the additive property. This is the meaning of additive property. Let us consider one system. You can design system easily because the basic concept of system is system will have input, and corresponding to this input a system will give you output. So you can easily design the system. This is a system. This is a system, and the component of this system or element of this system is resistance, connecting wire and cell. So through cell, connecting wire and resistance, you can make a system, because if you will give input 10 volt to this system, then this system will give you a response for this excitation. Response means you will get current in the circuit. Current in the circuit, and current will be according to Kirchhoff voltage law 10 by 2, 5 ampere. Current will be 5 ampere. Now, let us consider the same system, 2 ohm, connecting wire and cell. This is a system. This is a system. The value of resistance is 2 ohm. The system is same, but what you are doing is now you have changed its voltage from 10 volt to 20 volt. Means you are changing the excitation. And as you know, when you will change the excitation, obviously response will also change, because it is a condition, it is a property of system. Its response will be a function of excitation. So as you will change the excitation, obviously the value of its response you can calculate through Kirchhoff voltage law. It will be 20 by 2, it will be 10 ampere. Now, let us consider the third case for the same system. System means a resistance. System means a resistance. resistance, connecting wire, and cell. But what you are doing now is you are just adding these two excitation. So now excitation V3, which is V1 plus V2, is 30 volt. What you are getting here, its response I3. I3 will be 30 by 2, 15 ampere. And what is 15 ampere? 15 ampere is 10 ampere plus 5 ampere. And what is 30 volt? 30 volt is V1 plus V2. So in this example, you can see when you are adding these two excitation, these two response will also be added together. So you can say this system follow the property of additivity. So it is very simple. When you can say the system is following the property of additivity, so symbolically you can easily say that uh, if any system is giving you a response of y1t for excitation, x1t, and the same system is giving you a response y2t for excitation, x2t, then if this system obey additive property, it means when you will add these two excitation, when you will add these two excitation, then its response will also be added together. This is the meaning of additive property. And this is one component of the principle of superposition. If any system follow the principle of additivity, you can't say that it follow the principle of superposition, because superposition has second component also. Uh, the system will have to satisfy the principle of homogeneity also, then only the system will be linear. Now what is principle of homogeneity? What is the meaning of principle of homogeneity? It is very simple. Principle of homogeneity means uh, if this is a system A and this system is giving you a response yt for given excitation xt, and you are saying, or you can say I am saying that this system satisfying the principle of homogeneity. It means if system A is satisfying the principle of homogeneity, then if you will multiply its input by n, then its output or response will also multiply by n. This is the principle of homogeneity. If you will double the excitation, its response will also be double. Let us consider again this example. This is first case. And what is happening here? When you are doubling the excitation, when you are multiplying 2, in first case, the excitation is 10 volt. But in this case, excitation is 20 volt. So you just double its excitation. Then what you are getting, you can see here, its response is also double. Its response, earlier its response was 5 ampere, but now response is 10 ampere. So you can say this circuit satisfying the principle of homogeneity, because in this case, when I have multiplied its excitation by 2, its response is also multiplied by 2. So this circuit satisfies both the property of additivity and principle of homogeneity. So you can say this circuit is a linear system. This system is linear system. So principle of homogeneity means when you will multiply input, when you will multiply input by n, then its response or output will also be multiplied by n. Such type of system, you can say for such type of system, the system is following the principle of homogeneity. And if system follow these two conditions simultaneously, then only you can say this system is obeying the principle of superposition and hence it is a linear system. If it violates any of these two components, then you will say the principle is not obeying the principle of superposition. System is not obeying the principle of superposition. So it is non-linear circuit. So collectively you can say this is the principle of collectively how you can define linear system symbolically. So if system is linear, then for any excitation it will give you a response because it is a system. For any other excitation x to t, it will give you a response y to t. If you will add the excitation, if you will add these two excitation, then response will also be added. If you will add these two excitation, the response will also be added because already it is declared that the system is linear system. So it will follow the property of additivity. So response will also be added if the system will be linear. And not it will follow only additive property. It will also follow the principle of superposition. Principle of superposition means, principle of homogeneity. Principle of homogeneity means uh, if you will multiply, if you will multiply uh, A in its excitation, then A will also be multiplied in its response. If you will multiply B in excitation, then B will also be multiplied in the response. This is called principle of homogeneity. And when you will add these two, when you will add these two, when you will add these two, so in this there are both principle of homogeneity and additivity. Response will also be added according to property of additivity. So in one line you can say, this is one line definition for the principle of superposition because this statement include both uh, principle of homogeneity and additive property. So in one line you can say, uh, a system is linear only uh, when for excitation x1t, if the response is y1t, for excitation x2t, response is y2t, then if this system will be linear, then if the excitation will be in the form of this, then if excitation will be in form of this, its response will be in the same form. So this is the definition of a linear system. This is all about the linear system. So everything I have covered here in PDF file. So go through that PDF file, which is already given to you, and for the better understanding of the linear system. So here it is explained. The linear system will follow principle of superposition. Superposition will have two component, principle of homogeneity and principle of additivity, and both condition must be followed. Then you can say the given system is obeying superposition principle, and this is the meaning of additive property. And already I have explained the meaning of additive property and principle of homogeneity. So you can see here, if the input is in form of this, output will be in this form. So this is the mathematical representation of the linear system. So this is very important. In problem, I will consider this uh, concept to solve the problem related to linear system. So only you have to remember, if the system is linear and this system is giving you a response y1t for excitation x1t and giving you a response y2t for excitation x2t, then if the system will be linear and then if excitation is in form of this, then the response will also be in the same form. Means it will satisfy both the principle of homogeneity and principle of additivity. This equation include both of these conditions. So you must remember this condition only to solve the problem related to the linear system. So in next lecture I will upload video on uh, numerical example based on linear system, and then I will discuss about time variant and time invariant system in stable and unstable system, causal, non-causal and static and dynamic system.